Hop in guys, let's go. Hey guys, welcome to my new autonomous vehicle.
What the?
Where are you guys running? AV is the future, dude.
Greetings to all, we're Team Caravan, and we're here to solve the problem of fear, uncertainty, and doubt, better known as FUD, towards self-driving cars and the safety concern covering it. Our team will be using statistical model to first identify key aspects of why people are afraid of AVs. Ultimately, we strive to use statistics to develop innovative solutions that will change the public's perception towards AV and convince them that this is safe.
So, with regards to the FUD of autonomous vehicles, Singapore itself already has a dedicated area to testing autonomous vehicles at One North. So, as you can see, even though AV's technological capabilities are advancing, the thing that prevents it from being adopted would be the public's perception on it. So, the public is mainly concerned with intrinsic and extrinsic factors with regards to safety. Let's discuss more. So, for most people, safety can be broken down into extrinsic and intrinsic factors. So, throughout the presentation, our team will bring you through the difference between the both factors. So, let's go!
To collect data, our team compiled a list of questions on Google Forms. These questions included their gender, age, driving experience, as well as the level of trust and exposure towards AVs.
From the information we've collected, we've quantified trust levels through numbers 1 to 10, with number 1 indicating no trust in AVs at all, to 10 being trust AVs a lot. Since middle ground is at 5, we treat numbers 1 to 4 as individuals not trusting that AVs are safe, and numbers 5 and above as them trusting that AVs are safe. Our null hypothesis is mu being greater than and equal to 5, and h1 being mu lesser than 5. But before we proceed to deciding a suitable test statistic, we have to see the distribution can be approximated by the central limit theorem to be treated as a normal distribution. For CRT to be applied, we need to have a large sample size. And since our sample size is 33, we can consider it large and therefore use CRT to proceed with our calculations. However, as we do not have the population variance, we must apply the t-distribution to derive our p-value using the sample standard deviation. As p-value is less than 0.01, we reject h0 at the 1% level of significance and conclude that individuals perceive AVs to be unsafe.
So, with regards to the data we collected, we wanted to gather a 99% confidence interval for RVX as a sample mean of trust for AVs by Singaporeans. Given this scenario, we do not have access to the population variance and thus have to estimate using sample standard deviation in R. Therefore, to discover the confidence interval, we have to use the t-distribution. The t-distribution only takes in one parameter, which is the degree of freedom n-1. Through R, we are able to calculate the 99% confidence interval of trust between the lower limit of 5.23 to 7.93. Interpreting this result, there is a 99% chance that the confidence interval contains the true sample mean of x within its calculations.
Our goal is to prove that there is a strong positive correlation between users' exposure to autonomous vehicle and their level of trust for autonomous vehicle. After collecting data regarding users' trust level for autonomous vehicle, depending on their exposure rate to AV, we loaded the data into R and ran some codes to find out the correlation and covariance values between trust and exposure, which we found to have a very strong positive correlation as shown by the value being 0.92, which is very close to 1. This means that an increase in exposure may lead to an increase in trust for AV. However, even though there is a strong correlation between exposure and trust towards AV, it is important to note that correlation measures association but doesn't show if exposure rate causes trust to change or vice versa, or if the association is caused by a third factor. Thus, we need to incorporate a linear regression model to further prove that an increase in exposure rate will help improve users' trust level for AV.
Lastly, we'll look into regression analysis, which is the relationship between variables. With the data that we've collected, we're curious about estimating the linear relationship regarding how the independent variable, such as education and age, will affect the trust in AI algorithm in autonomous vehicle, as well as the extent of the effect. We have decided to conduct regression analysis with the dependent variable as trust in algorithm, as well as trust in sensor, so that we will be able to examine an aspect of both the intrinsic and extrinsic element of AV. On this site is a summary of the regression analysis. And from this, we can derive the following equation of the number representing the coefficient of correlation, which is the strength of the linear relationship between the independent and dependent variable. Thus, from the result of this data, it can be concluded that the variables in education and driver's experience is significant and positively associated with trust in AI algorithm at 1% significance level. Furthermore, the variable age is significantly and negatively associated with trust in AI at 1% significant level. And last but not least, through this data, we can theorize that gender does not have a significant influence and relationship with the trust in AI algorithm.
Regarding the extrinsic factor, when examined the linear relationship between the dependent variable, which is the trust in the sensor, and the independent variable of the driver's education, driving experience, age, and gender, we have evaluated and generated the linear regression model for analytics to separate signal from noise. Over here, this is a summary of the linear regression model for the extrinsic factor. Similarly, from the results and data, it can be concluded that the variables, education, and driver's experience are significantly and positively associated with trust in a sensor at 1% significance level. In addition, the gender female is significantly and negatively associated with trust in the sensor. Furthermore, since p-value for the variable age is 0.670, we reject it at 10% significance level and the variable age is insignificant. With these results, education is the most significant dependent variable.
With the results of our analysis, our team has brainstormed two solutions that could help reduce the FUD towards AVs. Firstly, by adopting simulators to increase user exposure in a safe yet authentic manner. Next, by implementing an AV-only lane on highways to reduce the likelihood of accidents caused by extrinsic factors.
So as for the implementation of our solutions into other industries, one example we thought of was the public transport industry, where there can be an adoption of autonomous public transport vehicles to replace bus captains who are likely to be fatigued after a long day of driving. This will cut down on the probability of accidents as a result of human inefficiencies. Another example our group thought of is the construction industry. By implementing autonomous construction vehicles, this reduces the need for construction workers to operate, which will minimize their risk of injury at work.
In conclusion, our team has used regression analysis to identify that in terms of intrinsic and extrinsic factors of safety, education plays a huge role in the public's perception. Interestingly, gender also plays a huge role in the perception of extrinsic factors. Our data collected reached a sample size of 33, allowing us to use the Z distribution to generate a p-value of 0.99, which is greater than alpha at 0.01. Therefore, we should not reject H now at the 1% significant level. Lastly, we calculated a confidence interval of 99%, where X represents the trust of Singaporeans' trust towards AV between 5.26 and 7.93. This is the end of our presentation, and we thank you.